Hi everyone. So I'm Benoit. Thanks to be there to listen to me. We'll talk about something new. I'm used to talk about Barrel. This is somehow related, but this is my new choice, which is GAN persist. It's used to be called GAN persistence, but I shortened it recently. So this is still a work slowly improving, but it's also entering semi-production recently into customer sites. Because all of us today are playing with OTP and playing with GAN server, GAN Statem, etc., which are all nice features, but I always think there is something missing because we always are redoing the same works. When you want to build some kind of consensus like Raft, or to build some kind of reliable casting, or if you want to simply build the logs on your file system, etc., you are always redoing the same thing, passing events to your process, try to figure out how to make it consistent, and try to figure out how to read that concurrently, independently of the writes. And this is all what I tried in that new GAN persist. So GAN persist is about persisting the state of your processes. What does it mean and why it's useful? So I already said that. When I'm saying storing the state in the on the storage, this is not about storing the state by itself, but storing the events that came to that state over the time. Of course, you can sometimes you want sometimes storing a snapshot to go faster, but this is all about storing the events and replaying them when you process come back from the file systems. So you persist the state of your process, and all your state is recovered on start. And on start, it means that you may have closed your process for any reason and want to restart it from a fresh state because you want to change your states or depending on the events you will have on it, or because your system is crashed and you restart, or because you simply migrated your system to another cluster. And because you are persisting your states on the storage, so you can have a local storage, like I'm using right now, but you can also have storage like Postgres, Cassandra, or Azure, Cosmos DB, or whatever you want to. And by doing that, then migrating your processes, migrating your machine from one machine to the another machine is very simple. You're persisting your state and restart your process on another machine. And when it started, then close the other process. You migrated your process from one cluster to the other. That simply. So like I said, the events are stored, not the set itself. So let's have a quick glance of that things. So everything starts very simply, just like you start a GAN server. You are starting a persistent process on which you put a persistent ID. This persistent ID is unique for that process on that storage. So when you start a process, you have to make sure of course, that only one can use. There are some prevention, but if you are trying to write to the same persistent ID, then your state will be corrupt at some point. And then you have different commands, just like for GAN server or GAN Statem or whatever. You have two main callbacks. Basically, you have handle commands, which may be called handle message for the final public release, but it's now called handle commands. Unlike GAN Statem, you can cast a message to that handle commands or call a command to that and get a reply from. So you cast here, I'm casting a hello message, which is received by the handle commands. And you can see I'm simply persisting that to the default storage there, but I could have set up a different storage when starting my process. Here I'm simply storing the message as binary to the file systems. And when it's persisted, so the persisting is atomic. When it's persisted, then an event is received by the handle event function callbacks, and that event is a map that consisted in one sequence, which is a sequence monotonically increasing sequence over the time, Oops. Okay. Where I am. Here it is. So you have that monotonically increasing sequence over the time, which is a basic integer here. And you have the data that you pass from the persistent procedure, which means that on the handle events, then you can do anything. So you can update your states from that event stored persisted, or you can also send any events. Yes. And so and you can forward an event to another process. So you can basically do two parts of the event sourcing there. You can handle your comment, persist it, do something, reply to the caller, and you can also pass this event to the event system and then do the event source part, source your events to another process and forward it, etc. So persisting is synchronous and appended in storage, on the storage as logs, and when persisting is happening, like I said, you are getting an event in all the handle events function, but in between, nothing happened. All other messages are postponed and will be replayed later once you did something with the handle events, which allows you to do really the event sourcing part, persisting your state on the storage, do something with the command, and eventually source that event to another process. And when persist happen, there is also a notification system, so you can subscribe to all the events and do something in real time to that. And yes, because I forgot that slide. And because all the infrastructure, like I said, is so you have that persistence process as we saw. You have all the event happen into a journal. You can do some snapshot. We will see that later. The journal and the snapshot storage are all pluggable. So by default, you have two. Currently, you have two storage that are created. One is over Cassandra and one is over RocksDB. The RocksDB is local, of course, and Cassandra is on the cluster somewhere, if you want to. And you can do even those things. So okay, going back to that. So, like I said, when persisting happens, the event is also notified to a subscriber. But what happens if your storage is failing, if you fail to persist? So, the first thing is that you will get an information to your process in the handle info, like all gain server. And the second thing is that the event will be replayed and start to be persisted again. And if it really doesn't persist, then your process will crash because you are at risk and you don't want to corrupt your state. This is what is happening. So remember in my startling, I also created send after events to let it do some snapshotting from time to time. So every 1 second, for example, I'm persisting a state, a checkpoint of all the events on the file systems. Which allows me, when I restart the process later, and we saw that a little later, that allows me to just go from that snapshot and take only the event over that snapshot that happened over that snapshot. So I don't have to replay everything from the start, which is very useful over the time. So you can do one persist, or you can also nest all the persist inside your process. So in the handle commands, we get that message. If I want to persist 2 events based on that message, I can do a persist of the 2 events. These persist functions are synchronous. So it will persist, wait that the event is sent, start to persist the others, and the events are received in the handle event functions. Then you can see at the bottom that the first event is received, the LO1 is received, the LO2 is received then, and in my handle event I also decided to persist an event depending on that, and I will get that event in the order they happen also after the main 2 events. So I can do some inlining of the events, which is very useful when you want to do some kind of event sourcings based on that. something also that can be useful here, you have that persist function, which is synchronous. But if you don't want to wait or don't care about the order of the events, you can also use the persist async function and just like spanning a process, persisting that to the systems, and eventually the event will come back to the underlying event function. Of course, if the process crash, you will have lost that event. You don't have the security that provide the static, the atomic persisting functions, but that can be useful when you are overloaded on your process or you don't care about losing some events. And once you persisted your states, from time to time you want to migrate, like I said, your process to another machine, or you want to restart your machine because it crashed or because you needed to upgrade it for any reason. So you stop your machine, the process is stopped, then you restart your machine. The process, which is like any process in Erlang can be supervised, is started again. Using that persistent ID, it will get the events, and then the systems of persist will get the first snapshot, if any snapshot exists, pass it to the handle recover callback. Then you do something with the snapshot. Here I'm just saying that my latest snapshot is creating my new state. And then you will get all the events from that snapshot. Right after that, you can replay and recreate your state or migrate to a new state if you change the domain of your event, if you change the schema of your event if you want it to. Something like this. And this is how you can recover a persisted state at any times. So just the writes are optimized. All the writes are mostly batch over the time. So when you are sending a sync, Chronos persisting, it's going to a batch process. And when the batch started to be large, or when the things are starting to slow, it starts to write to the file systems, write fast, and then send the events. You have also the possibility to send multiple events at once if you want to do something more complex and create atomic updates using the persist all functions. And that function will be taken in priority by the storage plugin and store on the file system at once automatically. You can add some events adapters. So from time to time, when you pass the events from the persist functions, you may want to do something fancy with your storage. You may want to serialize it to JSON if you want to, or serialize it to anything, or maybe add some information because your storage plugin allows that, like we can see later. You can add event handlers to your process. This event handlers has two functions, to journal and from journal, and they get the events that are creating from the persisting function before they are sending to the journal, transformed by that function, passed to the journal and stored, and you get the reverse using the from journal functions. And this is all optional. You can use one or the two functions if you want to. So you can create it start to date. So you can create multiple plugins. This is very useful, and everything is instrumentable today. As of today, using opensource, so you can know at any time how many messages you have. You can trace anything, etc. in the systems coming from your application or other applications over the networks. Because storing is not enough, you can query. Persisting is a very synchronous system. You have a single writer, which is your main process. But reads can happen in parallel. You have two kinds of queries. You have the runtime events. So, like I said, anytime you persist, an event is sent in the systems. You can subscribe to that event and do something with that. You can also replay the journal from scratch. So you take the read from journals, depending on the persistence IDs, and do something with that replay. Maybe create another event, maybe store it somewhere else. And also, depending on the journal plugins, you can add some more queries. Okay, and you can add some more queries function, like the RocksDB process, like we will say just right after, allows you to store tags, to tag all your events and do some queries by tags. Here, for example, we are, so I'm speaking about the RocksDB storage. So we have that persist ID. I'm passing an option, which is an event adapters, which gets the modules. And in the tutorial events, in that modules, I get the events. I process that events. Sorry for the plural. I get some tags. I'm adding that tags to the event, and that event will be stored with tag. With the RocksDB plugin, then you can query by tag and filter by tag all the events that came to that. And this is persisted very synchronously. And I'm done. So this is open source this month. This will be under Apache license 2. What is missing is the documentation, more coverage. Also, this is very, very low level right now. And if you want to access to the beta, just drop me a mail at that mail. And if you get it, welcome. Anywhere on the current API IDs also are welcome, etc. Thank you.
So when you restore your server from these logs, and but what about when you replay those events? You might get side effects that you didn't want when you restore the state.
So yeah, so you have some back pressure inside. So first, all the events are not loaded at once, so they are not recovering at the same time. So you can limit the number of processes that are going back from the storage. That's the first things. And the second thing, then, if you are storing a snapshot in how often, then you only are storing from the snapshot. So this is very fast at some point.
Thanks. One of the advantages of letting it crash is that you reset your process to a state that was known, that you know works. And now with a persistent state, you might reset it continuously into a state where it crashes. How do you recommend selecting whether you want to persist the state or not?
So first, if it's crashed, then there is no chance that it has persisted what has crashed the server. So you are restoring from the last time before it crashed. And the second, then, when in that recovering function, you get the events, so you can have some kind of logic to your application to recheck the events to make sure that the history later can be fixed or something, or doing something convergent, depending on what you want to. Okay.
You mentioned that you're writing in batches, which means that you could return success to the caller when event hasn't been written yet. Did I understand it correctly?
No. So it's written in batches, so we can optimize the way it's written to the file system. So depending on the storage it's used or not. But depending on the storage, then you get the batch, and it can write faster if the batch is enough fast to the disk. But the event is only sent when it has been stored on the file system or on the storage.
I'm going to ask a question that's more specific to my use case.
Mm-hmm.
So I would be very interested in something like that because I program grist boards that basically I must assume they can get struck by lightning at any time,
Yes.
even at the exact moment before the transaction is correctly closed.
Mm-hmm.
So, for example, with DETS, this is exactly the case that has been explained. My system keeps on rebooting into a crashing state.
Yes.
Would this be a solution to avoid this easily all the time?
At least it is storing, depending on the backend, of course. you are storing a logs of a journal of events. So, if you are storing that fast on the file system, then it's very well done for the embedded hardware, because this is what you are doing on embedding hardware. You are storing logs of stuff and generally passing that to the other storage. And then here you are storing your logs and doing materialize the information you want asynchronously and independently of the writing. So yes, I would say it could work in that case. Okay. Thank you.
Any more questions? Well, thank you very much for the talk, and please remember to leave feedback on the Wahoo app.
Thank you.